Hey everybody! See, I changed up. I didn't say hello. I just wanted to go over the long answer questions from exam 3. This is the answer key to question number 1. And this is a thermodynamics question through and through. And it's actually kind of a straightforward question where you have a settling gas, and acetylene gas is used in this reaction, and it's used in welding and all sorts of things, which the question outlines. But then we want to calculate the delta H, the delta S for the reaction, the delta G, and the equilibrium constant. So in these cases, all of these guys are dependent on the reaction and doing products minus the reaction. Reactants. Products minus the reactants. So let's just double check that everything is balanced. There's 4 carbons, 4 hydrogens, 4 hydrogens, 10 oxygens, 8, 10 oxygens. Everything's balanced. So now we can do our determining delta H. So delta H of the reaction is equal to the summation of the delta of N, the number of moles, of the delta H of formation of the products minus the number of moles of the delta H of formation of the reactants. Okay? And so because we have a balanced chemical equation, everything should work out. We're going to solve for this. So delta H reaction equals, and so now we need to know which one is delta. I bet you that one. Yeah, delta. The delta H of formation. So I always put it in brackets. And so the products, there's 4 carbon dioxides times negative 393.5. Okay. Plus 2, right? That's 2. That's 4. So that's there. 2H2O, which is 2 times negative 285.8. And that's the products minus, I think I'm going to have to move my calculator screen here, minus the reactants. And so that's a bracket. Just get that looking good here. So get that ready to go. Okay, minus the reactants, so it's 2 times acetylene, which is 227, plus, and I always include the elements, plus 5 times 0, because that communicates to the person grading it that you are you understand that this still plays a role in it, but in this case it's 0. So then, when I solve these problems, I take it by piece, because I feel like too much can go wrong if I plug it all in at once. So I usually take the products piece, and then the reactants piece, and then do the math on those things. So I have 4 times negative 393.5 plus 2 times negative 285.8. Okay? And so then that, we have negative 2145.6 minus, and then 2 times 227. I can do that in my head as negative 454. Okay, and then when we do that, so now we go minus 454, and then that answer is that the delta H of the reaction is equal to just about negative 2600 kilojoules. Perfect. Okay, so now we're going to do the same thing with delta S. Delta S, so the delta S of the reaction equals number of moles times the standard entropy of the products minus the number of moles times the standard entropy of the reactants. And we merely plug this in. Now we can solve, and so I like to solve in pieces. So this piece, okay, the products piece, that's not negative. So this side is 994.6 minus, now we do the reactant side. So now we can take these and do the math and get the final delta S naught of the reaction. And so that is so we get negative 432.2, and that's in joules per Kelvin. So now the last is my voice finally cracks in its puberty, okay, is finding the delta G. It's not the last part, but it's the last like thermodynamic value that we do. And so delta G equals delta H minus T delta S. And so that we have to know that we need both units to equal. This one's in joules and this one's in kilojoules. And so I'm going to do kilojoules because I like kilojoules a little bit better. And so now we plug in this value, 2600, negative 2600 minus the temperature. And when I go back up and look, the temperature is 25 degrees Celsius, which is 298 Kelvin. So minus 298 Kelvin times negative, and now this, 1, 2, 3, move that over 3 spots, and we get 0.4322. And now we plug it into the calculator. So we get negative 2600 minus 298 times negative 0.4322. Only couple of 2's. And so now the delta G for this, delta G equals negative 2471. Okay. Now we have to calculate the equilibrium constant. The formula for calculating the equilibrium constant, delta G equals negative RT ln K. Now, We have the delta G, we have R, we have T. Now, keep in mind this is in kilojoules, so now we want to move this back to joules. So this is 24,700. So it's, sorry, 2,471,000 joules minus 8.31 joules per mole Kelvin. That there is the universal gas constant with units of energy times temperature, 298, and that is multiplied by the natural log of K. So now we do this. So 27, let me do this side. Negative 8.31 times 298. And so I'm going to get an answer to that side. Okay, so that's good. And now I'm going to go 2, and then I'm going to take 2471000. I'm going to divide it by the answer. Oh, and that delta G is negative up here, right? I missed the negative. How can I have missed? Oh, no, I got the negative sign up there. Okay, and so now we get negative 997 equals the ln of K. And so to get rid of the ln, we go E raised to the power of, and so E raised to the power of. And so this is the answer, because if we probably do E to the negative 997, not negative, it's positive. This is positive, because negative, negative, positive. Okay, if we do that, I'm having a bad calculator moment with this particular problem. So if we do the, E to 997, that's going to give us some sort of crazy error because it's there's too much data there. So it's just going to have to stay in that answer. Okay, so there is long answer question number 1. Hope you loved it.